Okay, so I've got 3 cables attached to this uniform plate as shown here, and I want to find, uh, how much that the plate can weigh if the maximum tension in the cable, any cable, is 15 kilograms or kilonewtons, excuse me. So first thing I need to kind of recognize is kind of do an overarching look at what's going on, right? I've got mg acting straight down like this, and that's really what I'm trying to find. Now, if I think about it, that means then I've got on this heading up, I've got the same mg acting straight up, right? And I do that because all of those converge at point A. Okay, so I'm going to draw mg going up, and then I've got all of these forces heading in their respective directions. I've got FD, I've got FC, and I've got FB like that. And again, mg is going to be 9.8 times m, and m is really what I'm looking for. Now again, one of these cables has to be 15 kilonewtons. All the other ones have to be less than that, and that's what we're trying to do. It's not that you set them all to 15 kilonewtons and see what happens. It doesn't work that way. So there's my free body diagram. Again, you draw it at point A, so you actually draw your reaction of the gravity going upward, the 9.8, and then their tensions going down as shown. So that's how we're going to write our Cartesian form of each of these forces moving forward. So we'll start with FB, and I'm going to get that FB times 4 minus, 4I minus 6J minus 12K. And believe me that when I do that, it's divided by 14. Okay, square root of the sum of the squares will give me 14 on that. Okay, FC is going to be, again, my unknown, and that's going to be negative 6I minus 4J, and it's also minus 12 in the K. So this is another one, square root of the sum of the squares is going to be 14. Okay, FD. Okay, take my unknown force FD, and I say, okay, negative 4I plus 6J, and then again also minus 12K. And again, that length is 14, square root of the, 4 squared plus 6 squared plus 12 squared gives me that 14. Okay. I have also got what I'm calling my weight. I'll throw that up over here, and that's going to be 9.8 times m, and that's in the k direction. Okay, so those are all of my forces. So now what I'm going to do is I'm going to sum all of those x, y, and z components. Okay, so start with my x components. Okay, and I'm basically going to divide everything by 2. So instead of 4/14, I'm going to do 2/7. Okay, so that's 2/7 FB minus 3/7 FC minus 2/7 FD, and that's going to equal 0 in the x direction. In the y direction, it'll look pretty similar. Again, instead of 6/14, I'm going to use 3/7. So it'll be minus 3/7 FB minus 2/7 FC plus 3/7 FD, that equals 0. Sum the forces in the z direction. These are all going to be negative 6/7. So that's going to be 6/7 FB minus 6/7 FC minus 6/7 FD. And then remember, you've got your weight in the z direction. So that's going to be plus 9.8 m equals 0. So I've got 3 equations, but I have 4 unknowns, right? FB, FC, and FD, and then m, which is what I'm looking for. Of course, what I know is one of those forces is 15 kilonewtons. I just have to figure out which one it is. So what I'm going to do is I'm going to solve a system of equations using my calculator or Wolfram Alpha, something like that, to figure out what those forces are in terms of the mass. And when I do that, I find that FB equals 5.27 times the mass. FC actually equals 0, and FD equals the same thing as FB. Okay, so when I solve that system of equations using various methods that I don't have time to show right now, okay, we find that. So all I do is I take one of those forces, set it equal to 15,000 newtons. And from that, I can solve my M equal to 2,624, and that's going to be in kilograms. And that's the total mass that I can lift with these cables that can each hold up to 15,000 kilonewtons.